Okay, CPI. No, not CPI. Goodness gracious. Carbon dioxide emissions. It's too late. I should go to bed. All right, so this is on page 351 in your packet. So we will start with number 1 here. If your car holds 15 gallons of gas, how many pounds of CO2 are produced if you burn the entire tank? Now, they talk about CO2 and we're talking about gasoline. So you know that you are going to be using 19.8 pounds compared to 1 gallon of gas. That has to be your last identity ratio in your line. So if you think about working backwards with these, depending on how your mind works, you know you need to get rid of these gallons. So gallons have to go on top, right? You need them in opposite positions. So if I look up in my problem, I know that I have 15 gallons, period. Like it's not gallons per anything, it's just 15 gallons. So that would go over 1. So that means my gallons would cancel out, and now I can multiply because I want pounds, right? This is a simple one-step conversion, and that's it. And I would produce 297 pounds of CO2 if I burned 15 gallons of gas. Okay. Now in number 2, we get a little bit more involved. You plan to drive to Disney World for vacation. You've got 950 miles. How much CO2 is emitted if your car averages 30 miles per gallon? Again, lots of information here, but CO2, and we're talking about gas, right? You're driving and there's gallons, right? That means gasoline. So you know the last piece of this is 19.8 pounds over 1 gallon. If you struggle with, I don't know where to start, I don't know what to do, start at the end. Work backwards. It'll get you there. So this is an ending, and I've got to work backwards. Again, gallons is in the bottom, so gallons has to go on the top. And the only place I see gallons is right here, 30 miles per gallon. Remember that per is the division line. So this word here represents that line that I just did. Okay, so when I am looking at this, 30 miles per 1 gallon. So that means 1 gallon is 30 miles because that's the conversion that I had in my statement. So that right there makes my gallons go away. Well, now I have pounds on the top and miles on the bottom. I don't want miles on the bottom because the question says how much CO2. So I'm not done. I've got to keep working backwards, and this time I've got to get rid of miles. So no problem. I know that the trip is 950 miles, period. So it goes over 1. That process right there makes my miles go away. And now my only label is pounds. So I will take 950, divide it by 30, multiply by 19.8. And if I take this trip to Disney World, I will produce 627 pounds of CO2 from the gasoline. All right. Number 3, during which of the following trips would your car emit more CO2? Using a car that averages 15 miles a gallon to travel 150 miles, or using a car that averages 28 miles a gallon to travel 300 miles. Okay, I did not leave myself extra room. Shocker. Okay, part A. I know that I'm going 150 miles. I'm going forward on this problem. 150 miles, because that will mean 15 miles will go on the bottom per 1 gallon on the top. And because we're talking about CO2, we know that 19.8 pounds is over 1 gallon of gas. It's pretty much just like the one that I just did, which is why I did it forward. But you could have started with, we know we're talking about CO2 in gallons of gas, so that would give us our 19.8 pounds over a gallon, and work backwards. So with our information here, gallons go away, miles go away, and multiply with the dividing by the number in the bottom. And this is 198 pounds of CO2, part A. Part B, using the same concept, I start with 300 miles. Well, I'm averaging 28 miles to the gallon, and I know that I am doing 19.8 pounds per gallon, right? Same process, just different numbers. Now my miles go away, my gallons go away. And when I do the math here, I get 212.14 pounds. That's an LB right there. So, in which trip would I emit more? Well, the second one. Even though I get better miles per gallon, I'm going twice as many miles without getting twice as much gas mileage. All right, so there's a couple gas problems. And now we've got electricity. Okay, so how much CO2 is produced each day if you use a toaster for 15 minutes to make your family breakfast? Okay, so we're using electricity. It's a toaster. So you look at page 108, I believe, has your wattages on it. And a toaster, oddly enough, uses 1,100 watts. And that's on page 108. And I actually just used a toaster like an hour and a half ago to make my dinner. I had a bagel. It was fantastic. So it didn't work for 15 minutes, but whatever. All right, so I need to change those watts to kilowatts. And you can do that a couple different ways. I generally just create this step here. But I want to kind of show you something that we did in class today, because I hadn't really thought about it, but somebody brought it up to me and it was good. So this allows me to go into it, but I know this step confuses a lot of people. So when you think, and I know you're gonna be like, why are you erasing that? Well, when you think about metric, so the metric system is kilowatts, and then we've got, oh crap, what's next? I think, pause. All right. Hecto, then deca, then the units, then deci, then centi, then milli. All right, so watts would be considered the unit here, and kilowatts is just 3 to the left. So if that first step kind of confuses you, just think of watts to kilowatts, we're moving 3 to the left. So, let me get rid of all of this. We could say our first step is to move my decimal 3 places to the left, so I'm really starting with 1.1 kilowatt. So that kind of eliminates a piece. It's the same step. So I'm going to kind of do it both ways just so you can see it. So I know right now you people want to kill me, and you know what? I don't even blame you. So either way, the bottom is where we moved it left 3 places first. The top one is where we just do the whole fraction. Either way, you're going to get the exact same answer. So this toaster, we're only using it for 15 minutes, but remember, after we change our watts to kilowatts, we need kilowatt hours. So I've got to multiply by how many hours I'm using this toaster. And if I'm using it for 15 minutes, that's a quarter of an hour. So that's 0.25 hours. All right. And now that I have kilowatt hours, so you see kilowatt hours, now I can use my CO2 ratio. So 1.37 pounds over 1 kilowatt hour. So you can see this kilowatt cancels out with that kilowatt. This hour cancels out with that hour. All right, same process on the bottom if you did it, but I need room for my answer. So now if I multiply, divide if you have to, either way, you should get 0.37675 pounds of CO2 for using your toaster for 15 minutes. So I used less than that because I did not even use a full 15 minutes of my toaster. All right, how much CO2 is produced if you use a curling iron for half an hour every day for a year? Okay, so curling iron. Curling iron is 90 watts. Well, I'm sorry, this is how I do these problems. 1,000 watts is 1 kilowatt. If you move the decimal, knock yourself out, you'll get the same answer. Okay, so I go watts to kilowatts, and now I need hours. Well, we said half of an hour, that's 0.5 hours, but every day for a year. So that's 0.5 hours in one day, and I know that there are 365 days in a year. So that will make my days go away. You don't have to put them in there at all if you don't want to, but you got to have 365 days because you're doing this every day for a year. Now that puts in, now I have kilowatt hours, so I'm going to have my 1.37 pounds times 1 kilowatt hour. And now kilowatt hour cancels out with kilowatt hour. And I will end up taking 90 divided by 1,000 times 0.5 times 365 times 1.37. And that gives me an answer of 22.5 pounds of CO2. All right, number 6. How much CO2 is produced if you vacuum your house for 1 hour every week for a year? All right, so we're talking about the vacuum. Vacuum is 500 watts. Watts has to get changed. There we go. Watts has to get changed to kilowatts. We had a minor technological glitch right there. All right, so watts go to kilowatts. And then we are ready to go to hours. Okay, so I'm houring 1 hour a week. 1 hour per week. Well, how many weeks are in a year? 52 weeks in a year. So that makes my watts cancel out. And now I have kilowatt hours. I need to write smaller. So 1.37 pounds is 1 kilowatt hour. Kilowatt hour cancels out with kilowatt hour. And again, just so we have our numbers right here, 500 divided by 1,000 times 52, because by 1, that doesn't change anything, and then times 1.37. So when I do that, I should end up with 35.62 pounds of CO2. All right. In the last problem, a little bit more in depth in this one. How much less CO2 is produced in a week if you open your windows and use a ceiling fan for 8 hours? That should have an H in front of it. 8 hours every day of the week, rather than running a room air conditioner for 8 hours every day of the week. Now you can do this 2 different ways, but if you think about it, let's just look at the room AC and compared to the ceiling fan, because we want to know the difference, right? So the room AC is 1,100 watts, and a ceiling fan is 100 watts. So the difference is 1,000 watts. So this is what we will save, right? We will save 1,000 watts in general by using the ceiling fan over the room AC. So it's very much recommended that this is how you do. Figure out how much wattage you're saving and then base everything off of that. So if we're saving 1,000 watts, well, watts to kilowatts. So that makes my watts go away. How many hours? Well, it says 8 hours every day of the week. So that's 8 hours, and there are 7 days in a week, right? So I would do the 8 hours a day, 7 days in a week, and that puts me in kilowatt hours, and then I can multiply by 1.37 pounds over 1 kilowatt hour. So kilowatt hour, there's my hours, there's my kilowatts, and then I can take my 1,000 divided by 1,000 times 8 times 7 times 1.37, and I should end up with 76.72 pounds. And I probably will have another one of these videos for this concept, because the more you do, the more you see, the easier it gets. So CO2, gasoline, and electricity, enjoy.